Good morning, Kilian.
Hi,
so
Oleg.
It's Laser World of Photonics. It's Friday, last day of the fair. How do you feel?
Pretty exhausted, but the traffic at our booth was good, so I'm pretty happy with the trade show so far.
Okay, cool. Could you explain what is presented here as a booth?
Sure. For the first time in our career, we opted for demonstrating our module live in action at the trade show floor. So what you can see here on the optical breadboard in front of us is a carbide laser from light conversion, our compression unit, and various diagnostics devices, an autocorrelator, spectrometer, power meter, and beam profiler.
And could you explain what is on this display shown?
Here you can see the live measurement results and the input parameters from the carbide laser currently running on the show floor. As it is configured now, we are running with 50 microjoules, 120 kilohertz, 6 watts average power directly from the carbide laser. This laser beam we directly guide into our module, into our compression unit. Inside the compression unit you can find a gas-filled multipass cell together with a chip mirror compressor.
What is the pressure currently in this cell?
Currently in this cell for 50 microjoules and 230 femtoseconds input pulse duration, we need around 11 bars gas pressure within the multipass cell.
Okay, cool. And could you also explain what this camera does? Is it part of the module?
Sure. On the bottom right-hand corner of the screen you see the diagnostics camera that's integrated into our module. We use it for two purposes. The first purpose is we check the mode matching, which is the compatibility of the input laser with our module. This is a crucial parameter we need to monitor during operation. And the second purpose is the camera serves as an alignment reference during the installation process of the module. You can see here that there are various colored crosshairs on the screen, and the technician who installs the module would need to align the beam with the two steering mirrors in front of the module such that the beam hits all the crosshairs.
Okay, great. And one more question is this self-phase modulated spectrum I see here, does it change with the input power?
It changes with the input peak power of the pulse. In this case, what we can do to demonstrate how it changes, we could vary the pulse energy while keeping the pulse duration of the carbide laser constant. So for example, I can go ahead and change the laser output energy, for example, to around 25 microjoules, and you would see the spectrum shrinks down, so the bandwidth gets narrower, and the pulse duration extends, it gets longer. If I reverse the process, it goes back to the old output parameters, around 40 femtoseconds, and the wide frequency bandwidth.
Could you please do it once more, so decrease and increase?
Okay, so I'm now decreasing the energy to around half.
Even more?
Now we are at around 15 microjoules, and I go back to full power, and we're back to full power. Yeah.
Thank you.
Thank you.